Today we are going to learn how to model the floodplain of the Marne River in France using elevation and vector data in QGIS. In this video we'll cover how to import and style a very high-resolution DEM, how to visualize topography using color and hill shading, and most importantly how to interpolate elevation values to help define the floodplain of the area of interest. QGIS is a free and open source GIS software that allows you to visualize, analyze and edit spatial data. So here is the area of interest. I will add the Google satellite view of this area of interest. You can see here the Marne River that we'll be working with. And here is one of the DEM, a digital elevation model we will be working with. So there are many tiles of this raster that we need first to make to fusion. So I'm gonna show you how many raster covers the entire area of interest. So you can see that there are 231 rasters for this area of interest. So I just want to show you where I had this beautiful raster at 1 meter resolution from that covers the entire front area. The dataset we will use for the very high resolution elevation data comes from the French National Institute of Geographic and Forest Information, IGN, specifically their 1 meter resolution digital terrain model, and is made available under the open license version 2.0. You can see the full management available in the description of this video. As a preliminary step, we perform a raster fusion of the tile from these datasets to ensure a complete coverage of the area of interest. So here you can see the Marne Valley with the area of interest, so Marne River. And the first step was to perform a raster fusion of all the tiles to have one raster DEM at the very high resolution. So to do this, you go to merge raster, and you have to select all the raster that you want to fusion. Okay. So I just gonna verify there's all the raster. Okay, so now I'm gonna choose okay, so now I'm gonna choose path for the output and then apply the process. This process may take a while because those 200 raster are pretty heavy, but in the end we have one very high resolution AOI Marne River raster. Once the process is done, you will see complete here. So you can close. Great. You can close this window, and you see that your from new raster layer come here, so you can have good projection for the area of interest you are. So for French projection, we will take this one. Now we will work with this raster to do the further investigation. So I'm just removing the previous tile, more than 200 previous tile, to only keep the big one raster to work with. Okay, great. So here is the digital elevation model we will be working with. We can see that here is the floodplain of the Marne River. The darkest pixels represents the lowest elevations, while the brightest one represents the highest elevations. The highest elevation should be up here, near Épernay-en-Champagne, the town you see here, because here is the upstream section of the Marne River, and over here is the downstream section. So what we're going to do now is to adjust the symbology of this raster in order to see the Marne River. So I'm going to go into the property of the raster symbology, and we are going to choose okay, I'm fine with this color ramp to go further with the investigation. So it is to know that all rivers have an inherent slope so that then water flows downhill. So here is the upstream section and here is the downstream section. So we have a gradient slope if we move like this following the river. And since we want to visualize the floodplain, we'll need to take this gradient slope into account in our analysis and remove the slope gradients to set the riverbed to be zero everywhere. And then the place outside of the riverbed represents the elevation above the riverbed. And that's why we call it a relative elevation model. Okay, so now I'm going to digitize the river, the center line of this channel, and then we are going to sample the elevation at that center line. We are going to interpolate those elevations outwards, and we're gonna subtract the interpolate elevations from their original DEM. So we are going to see the floodplain, and it will be the end of these investigations. Okay, let's go ahead. So I'm gonna copy layer and paste it here. So with this one, I'm gonna change the symbology to have a hill shade, and I'm going to change the Z factor, and I will set it to I don't know, 3. Okay, I'm going to choose this color ramp for the further investigation. Okay, great. Okay, so now what I'm gonna do is to create a new shapefile layer. You can create a new GeoParkit layer too, but what I'm going to do is to create a new shapefile layer. So I'm going to call it River Marne. Okay. I'm going to choose a line string because it will be the channel of the river and we want it to be a line. And I'm going to choose this projection because it's the right projection for the French projection for this project. Going to the OK. And then we have our beautiful sample line. So now, well, let's go with the digitizing activity. So I tried to stay at the center line of the channel of the river Marne. And let's go. Okay, great. Now we can save this line and exit the editing toolbox. So this line will represent the zero elevation, and we are going to sample this line to do our interpolation. What I want to do is to generate points on this line with equal spacing in order to determine what will be the equal distance I'm going to measure. Okay, that is the distance between what you can see. Oops. Okay, all right. Here you can see that is the river. So what I'm going to do is to space them at approximately 60 meters. I think 60 meters will be fine. So let's go back to our investigation. So I'm gonna open the toolbox and looking for align points to feature. Maybe this one is the right one, so points along geometry. So, and the input layer will be the river Marne, and here is the spacing between 2 points. So I'm gonna set 60 meters between 2 points and create those interpolated points. I'm gonna save this new file. River Marne interpolated points. I'm gonna run the process. And here we have our beautiful points along this geometry. So now what I'm going to do is to sample the raster values on each point of it. So I'm gonna choose sample raster values you see here. So an input layer, we want to process it with the river Marne interpolated points. So the raster value will be the DEM, and I will call it elevation area. Okay, so now I'm gonna remove previous, and we see that we have the elevation on each point along the channel Marne River. So now what we want to do is to interpolate those points to the entire raster. So we are going to looking for the IDW interpolation in the toolbox. So here I'm gonna set the interpolated points we will choose for the interpolation. Here we are gonna choose the attributes elevations for this raster. By default, the distance coefficient P is to 2. And here the pixel size in centimeters should be up to 1 meter, because our DEM is at the resolution of 1 meter. So we are gonna set those two values up to 10 to have the 1 meter resolution, to be the same resolution as our original DEM. And we are going to save this file. We are going to call it interpolated DEM. Okay, and we can. Oops. Oh yes, I forgot to add the layer here. So now we have oh, and to choose. Oh, sorry. We are going to use the AOI River Marne River AOI. Okay, this is a good projection, so now we can run the process. And we will have in output the raster interpolated. Okay, so here here is the river Marne, and if you can see that the highest values are here in white, and here are the lowest value in darkest color. So the next step will be to georeference my raster. So it's here. So we will choose a bilinear resampling method here. And if we go to the advanced parameters, we will choose the same projection. And here I'm gonna choose the high compression. And here I can choose from the same DEM. Okay, I'm gonna save this file. And run the process. Okay, so now we are going to calculate the relative elevation model. So it's very simple. We're going to take the raster calculator to open it and to subtract the DEM, the original DEM, with the resampled DEM. So the original is here, and I subtract with the interpolated raster. I can choose an output layer, so in geotype, so it's okay. The spatial extent seems to be good, and the CR is the right one for the French analysis here. So I'm gonna hit the button OK, and we have a beautiful Detrended DEM. So now we're gonna do some cleanup. I'm gonna just the symbology, so we are going to choose the same symbology than before. Yes, great. So everything is aligned with the elevation of the river. So now we can analyze the flooded plain of the river Marne. So I'm gonna do some adjust a little bit at 1 meter resolution. So now we have what we were looking for. We have the river Marne and all the values. We can see where is the floodplain, and what we're going to do now is to extract all the values, all the intervals we want in a vector layer. So now the next step, and maybe the last one, is to reclass this raster, this Detrended raster, in order to have classified polygon with equal interval of elevation above the river. So for example, we want all the values that are between 0 and 2 meters above the river. So what we're going to do is to, first thing, is to set all the values are between 0 and approximately 200. So we will have to prepare a text file like this one to reclass the raster. So we have to go to the toolbox and up to select the algorithm of the grass GIS air reclass, and now we can use our text file called intervals. So here we can set the extend area, so it's the AOR basically, and we can set a name to our new raster reclassified. Save file to reclass. Okay, and run the process. May take a while. Okay, great. Now we have a raster with many categories. So now we can extract the categories we want. Go to raster to polygons. Okay. You open and you see this new window. We want all the polygon from this raster. The bound number is the bound one, and the field name doesn't change. So you will save your file to a new vector file. River map. Classified polygons. And into this polygon we will have all the category we just set to this reclassified DEM, so all the value between 0 to 2 and all the value between 2 to 4 meters above the river and so on. So let's go run this process. Okay. So we have we can open the attribute table. And now we can see all the polygons with the value of the category. So we are going to select by expression. So maybe you want the value because values are selected, so this is all the polygons under 2 meters above the river. So we are going to save this polygon. Okay, and we see, so the next step is to dissolve this. Okay, great, so now we have we have the category like this. So you can play with the vectorized results, and we could make a beautiful map. So the last thing we could do is to look this map in 3D view. I'm gonna adjust the vertical square here. Yes, great. So we are going to do a new print layout. 3D view, floodplain, Marne River. Okay. Okay. and export it to see. So thank you for watching this video. Don't forget to subscribe to stay updated, and I hope this tutorial will help you to focus on your QGIS project.